So recently I set people who follow me on X and LinkedIn a little bit of a code challenge. It was just a sample few lines of code, and the question was, is this code vulnerable? So let's just go over the code. So all we're basically doing is we're looking for if there is a query string called username. We assign that username to a variable called username. And here we're actually doing a regex match, or a regular expression match. And that's just to make sure that the string only contains the lowercase letters A to Z, the uppercase letters A to Z, 0 to 9, spaces, hyphens, and underscores, and that the username is between 3 and 100 characters long. Afterwards, we're going to take this username and use it in this SQL string to just simply query a database. It's going to select the username column from users where the username equals and then our provided username. So this certainly attracted a few different answers. Some people who said, okay, this is secure because we're doing a match on the characters. A few people quite rightly pointing out that we shouldn't use concatenations when we're creating SQL queries, and that we should definitely be using prepared statements. 100% in best practice we should do this. But the question is, what's the harm? If you've already filtered that string to make sure it could contain no dangerous input, surely what's the damage? So the SQL query obviously brought a lot of attention, and people's focus was on that point. So that was only really there to show the potential impact of what could go wrong. The main focus was actually on this regular expression pattern. So let's use regex101.com, where we can paste in our regular expression and we can start explaining how this works. So from my explanation, and also the comment above in the code explaining what characters could be used, let's try this. So let's put my example usual username of build hack secure. And of course, this has all come up in blue because that meets the criteria of the regular expression. Of course, we could potentially put hyphens in here. We could put underscores in here. And of course, we could put spaces in here, and this would be all valid. This is the impact it would have on the SQL string as well. So here we can see the actual code for the SQL string where the username is concatenated, and that would result in something like this. Select username from users where username equals build hack secure. But let's go back to our regular expression so we can actually break down how these character ranges work. So our first one is characters A to Z, then in uppercase A to Z, and then 0 to 9. But first we have to dig in to see how these character ranges work. So in computers, it's not stored as an actual A to Z in a character range, it's actually its decimal equivalent. So if we have a look at this ASCII table and we scroll down to the letter A, we can actually see that the decimal equivalent to this is 97. And it's kept as a binary string of 0, 1, 1, 0, 0, 0, 0, and then 1. So that's how it's stored in a computer, as a byte of 8 bits. And then if we scroll all the way down to Z, we can see this is the decimal value 122. So if we go back to our regular expression, and if we hover over the A to Z, you'll actually see that this matches anything in between the range 97 and 122, which is, of course, just represented by the letters A to Z. So every time you do a range in a regular expression, it's converting it to its decimal and then working out the numbers from and to, and that'll tell us which characters are allowed. Again, next we have the uppercase A to Z. So if we check these numbers, this is number 65, all the way down to 90, and we can confirm that as well by just hovering over this range, and we have 65 to 90. And then lastly, we have 0 to 9, which is 48 to 57. So that would only include these numbers. The issue is that the hyphen is actually a special character in regular expressions. So if you're wanting to use it literally, you need to make sure it has a backslash before it. But of course, in this vulnerable example, it isn't. So actually this last part where we have a space, a hyphen, and then an underscore, this is actually being treated like a range. So instead, we have anything from a space, which if we look this up in an ASCII table, is the decimal 32, all the way to an underscore, which is the decimal value of 95. So because this is actually, instead of allowing characters space, hyphen and underscore, it's actually now created a range which can accept characters with the decimal value 32 to 95. And if we look back at our ASCII table, this is where it gets dangerous, because all these extra characters are actually included. So now we have access to all these extra characters all the way down from 32. So we have these ones, we have numbers, we have colons, semicolons, and then of course we have all the capital letters, and down here to decimal 95. And we can actually test this in our regular expression by, for example, let's do a single quote. We can see that this is still accepted in here absolutely fine. So now we've actually been able to introduce single quotes into our username. So now we can actually start changing our username. And instead of just build hack secure, we could do a single quote, and then we could do a union, and then select, and then one, and then from, users, where, and let's think of another column. We could do maybe password equals, and then we could start putting some test passwords in there. So then if we could just copy this whole string, which we can see is passing the regular expression, let's copy that, and let's just take this to our notepad, and let's paste it into here where our username would go. And we can see we've actually now broken out of the string and we've performed SQL injection. And this is a union based one where we can actually start bringing back results from other columns, tables, or even databases that it has access to. As you can see, this is a really powerful example of why you must get regular expressions right and how quickly they can actually go wrong. All we had to simply do was add a backslash here, and we can see straight away this has now become invalid, and it is in fact only accepting spaces, hyphens and underscores as well. If you're interested in learning any more about regular expressions, where they can go wrong, or how hackers can actually utilize them to find vulnerabilities or even assets, we created a course on Hacking Hub called Regex for Hackers. Here we'll take you through the steps of actually learning how to read and write regular expressions. We'll teach you useful and common regular expressions that can be used in hacking. We'll show you where regular expressions can go wrong with different vulnerability types, how regular expressions can be used in code reviews and even building useful tools. And lastly, we'll go through how regular expressions can be used on websites such as GitHub to actually perform reconnaissance against companies. And make sure you check out the video description for a 50% voucher on this.